This is SpaceTime Series 24, Episode 121. Coming up on SpaceTime, a new study shows lunar volcanic activity lasted longer than previously thought. More evidence of water reaching the surface of the Jovian ice moon Europa. And the International Space Station destabilized again because of a faulty Russian engine burn. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study shows the moon may have been volcanically active far longer than previously thought. A series of reports in the journals Science and Nature shows lunar regolith collected by China's Chang-e 5 sample return mission are providing evidence of volcanic activity 800 to 900 million years longer than earlier estimates. The findings are based on analyses of basalt rock samples which are formed through volcanic activity, finding that the samples were dated to around 2 billion years ago. One of the study's authors, Professor Alexander Nemchin from Curtin University, says these are the youngest volcanic rocks identified on the moon so far. The findings extend science's understanding of the period of lunar volcanic activity, which was previously thought to have ended around 2.8 billion years ago. The new studies also analysed the water content and heat-producing elements within the rock, finding that the moon's surface became dehydrated due to prolonged volcanic activity and cooled off more slowly than previously thought. The new studies also suggest that the moon remained volcanically active for up to 900 million years longer than previous estimates. Chang-e 5's mission returned the first lunar sample since the Apollo and Lunar missions, which ended way back in the 1970s. And these were the first samples from a previously unvisited mare basalt. The researchers aged 47 basalt fragments with radiometric dating, finding that they were formed roughly 2.03 billion years ago. The Apollo and Lunar radio age samples were used to calibrate another aging method called crater counting chronology, an approach used to estimate the age of a planet's surface based on the number and nesting of crater impacts. The moon's crater counting chronology suggests volcanic activity as recently as 1 billion years ago. That creates a gap of 2 billion years between that suggestion and the age of the samples. And while the new samples have helped fill some of the gap of magmatic knowledge, they may also have introduced a new mystery. You see, the previous basaltic samples were all found to be made from a magma rich in a unique composition of potassium, rare earth elements and phosphorus, collectively known as creep, which can produce heat and was likely a key player in the moon's magmatic evolution. Problem is, the new samples don't have the same composition levels. See, the creep would have provided the heat to sustain longevity for young magma. However, these new results dispute that hypothesis, meaning scientists will now need to do a rethink of the mechanisms underlying the longevity of younger lunar magmatic activity. Nemchin says the new findings will help scientists identify new age-dating calibration points. The task will now turn to finding a mechanism that will help explain how this relatively recent heating of the moon may have supported the formation of basaltic magmas with temperatures exceeding 1,000 degrees Celsius and ultimately help researchers improve age dating for the entire solar system.
Well, they're rocks. They're similar to what we see on Earth pretty much. The only difference, they come from the moon. Well, I've been looking at these rocks for the last 10 years or so, starting with NASA samples and also some of the samples delivered by Soviet missions back in the 70s. And now we started looking at Chinese samples as well.
How do you get the Chinese samples? Do you go over to China? Do they provide them to you, or do you have to do the research there and then bring the data back for analysis?
At the moment, normally unwritten rule that whoever runs the mission usually has the priority to analyze the samples for the first 6 months or so. It's kind of between all agencies. So China at the moment doing the same thing. Chinese scientists got priority for analysis, but we've got these all good relationships with one of the groups in China, started a couple of decades ago, and they've got access. So everything was analyzed in China. We connect to the labs over there, and then we discuss it. We look at the samples over internet and try to analyze them over internet, so to speak.
And these were what, basaltic samples?
Yes, we started because the main aim of the mission was to bring young basalts, and then they expected to see the young basalts over there based on remote sensing. So we started with basalts. There are components in the soil, of course. There is a mix of everything available in the area, but basalts were first priority, so we started with them.
Where did the lander touch down? What part of the moon?
It's significantly to the west of all other landing sites, of all the polar sites. So it's completely new area. Significantly, it's several hundred kilometers to the west. They did try to land in on the basaltic plateau. So it's kind of, yes, of course, there are craters over there. But, ideally you want very flat or reasonably flat area to avoid any potential problems with landing because of relief or slope and so on. Because it is younger basalt, there's smaller number of craters, so it's a bit easier to land there.
And that's one of the interesting points, isn't it? This is the youngest rock so far dated from the moon, and that tells you something about when the event which caused these rocks to form occurred. Yeah,
of course. And the reason everybody wanted young basalt is because it's usually used in what is called cratering chronology, where you can count number of craters and then tell the age of any surface. If you go and then look at Mars or Mercury or any other small moon rotating around some of this planet, you can say, okay, if the surface has smaller number of craters, it's younger than the one next to it that has larger number of craters. And then so this type of relative chronology is developed many, many years ago. But lunar samples give us a chance to put it on the absolute scale. We've got this basalt delivered from the moon by all these different missions, and you can determine ages of them in the laboratory, and then you can relate number of craters to specific age. And then so you produce some sort of relationships between actual age and number of craters, and you can use it to date surfaces that you don't have samples on any other planet. And then so this young basalt was important simply because we never had any rocks like that. So this part of the relationships was always missing. And now we've got, so we can extend our ability to go to different planetary bodies and then date the surfaces.
I guess the idea is on the moon, you haven't got erosion and wind and water and things like that to change the surface, to modify the surface. So you've got to sort of go by crater numbers instead.
Yes, there are different techniques. Yes, obviously, moon is less eroded, even though because there is no atmosphere, there is a flux of small micrometeorites that continuously change
and things like that.
Yeah. They change the surface a bit, but not to the extent like Earth's surface is changing constantly, more or less. Yes, we can apply all these techniques. Craters degrade even on the surface of the moon a little bit, and then people thinking about applying this type of approach. You see if crater is very sharp, and then it's probably much younger, and then in time it will lose the sharpness. And again, you can play with this type of ideas. Nevertheless, this crater counting is kind of much more sophisticated and probably better way of dealing with it.
The same impacts which make the moon regolith so fine and powdery is also affecting larger structures as well, like craters.
Yeah, of course. It's all interlinked and quite complex kind of system. So a lot of our conclusions, well, they're not necessarily precise because our understanding of the process is not kind of final. It's always work in progress.
And what dating method did you use?
It's simple standard approach we use for a lot of samples, even samples on Earth. It relies on uranium decaying into lead in time. So you can measure uranium in a rock or any sample and lead in the same sample, and then looking at the proportion. This proportion is always linked to time that passed since sample formation.
And this is what, zircons?
Well, yeah, zircons is most common application in terrestrial samples. In lunar samples, there are other minerals. Zircon is present, but not in basalt. That basalt contain other similar minerals that also concentrate uranium a little bit, like phosphates, for example, and then some other zirconium-rich phases. Bedelite is another zirconium mineral that is used to date mafic rocks, so basaltic rocks, or that composition on Earth as well.
And how do you know that the minerals you're looking at are part of the lunar surface and not part of the impactor?
In most of the cases, these minerals do not necessarily found in meteorites that can potentially impact lunar surface. So they are not really present in impactors. And then also, of course, it's not just chronology. You're looking at the samples themselves, and you can assess what these particular minerals you date represent. And you can work out that they are part of crystallization of basalt itself rather than coming from somewhere else. To me, most important part is that we managed to bring this international group, and so it's collective effort to some extent. One of our co-authors said it's diplomacy by science, so to speak. And then this is, to me, is the most important part of this whole thing, that we working together on certain project that is interesting, and we all are interested in doing it.
Science trumps the politics.
Yeah, to a degree, as much as we can.
That's Professor Alexander Nemchin from Curtin University. This is Space Time. And just a quick reminder, if you want more Space Time, don't forget to check out our blog, where you'll find all the stuff which we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. Still to come, more evidence of water on the surface of the Jovian ice moon Europa. And another faulty Russian engine burn destabilizes the International Space Station. All that and more still to come on Space Time. New observations by NASA's Hubble Space Telescope have found fresh evidence of persistent water vapour on the Jovian ice moon Europa. But the findings, reported in the journal Geophysical Research Letters, mysteriously only show the water vapour being detected in one hemisphere. Europa harbours a vast global subsurface liquid water ocean deep beneath its icy crust. This huge ocean, which contains more water than all the Earth's oceans combined, might offer conditions capable of supporting life. Previous observations of water vapour on Europa have always been associated with plumes erupting through the ice, sort of analogous to geysers on Earth, but shooting up hundreds of kilometres into space. These produce transient blobs of water vapour in Europa's exosphere, which is only about 1/1000th the surface pressure of Earth's atmosphere. The new Hubble observation, spanning 1999 through to 2015, shows similar amounts of water vapour spanning over a huge area of Europa's trailing hemisphere as it orbits around Jupiter. The cause of this asymmetry between the leading and trailing hemispheres isn't fully understood. The discovery was gleaned from a new analysis of Hubble archival images and spectra, using a technique that recently resulted in the discovery of water vapour in the atmosphere of Jupiter's giant moon Ganymede. The discovery of water vapour on Ganymede and on the trailing side of Europa advances science's understanding of the atmospheres of these icy moons. However, the detection of a stable water abundance on Europa is far more surprising than what it was on Ganymede. That's because Europa's surface temperatures are lower than Ganymede's. See, Europa's white icy surface reflects a lot more sunlight than Ganymede's surface does, and that keeps surface temperatures some 15 degrees Celsius cooler than on Ganymede. It means a daytime high on Europa of minus 162 degrees Celsius. Yet even at the lower temperatures, the new observation suggests water ice is still sublimating into space, that is, transforming directly from solid to vapour without a liquid phase off Europa's surface, just like on Ganymede. This detection paves the way for in-depth studies of Europa by future probes, including NASA's Europa Clipper mission and the European Space Agency's Jupiter Icy Moons Explorer. And of course, understanding the formation and evolution of Jupiter and its moons also helps astronomers gain fresh insights into Jovian-like planets around other stars. This is SpaceTime. SpaceTime is designed to provide accurate and educational science, news and information accessible to everyone. You can help support our work by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com and click on the Support SpaceTime button. Still to come, Russia has again destabilised the International Space Station with another faulty engine burn, and later in the science report, a new study shows more than half of people who get COVID-19 end up with long COVID. All that and more still to come on SpaceTime. Russia have again destabilised the International Space Station due to a faulty engine burn. The latest incident occurred during tests of the engines of the Soyuz MS-18 spacecraft, which would later be used to return a Russian film crew to Earth after shooting 40 minutes of footage for a feature film aboard the orbiting outpost. NASA says the Soyuz thruster firing unexpectedly continued after the end of the test window, resulting in a loss of attitude control for the space station. It's understood the crew couldn't shut the engines down, and they only stopped firing when they ran out of fuel. This engine burn tilted the space station some 57 degrees out of its normal orientation. And all that's critical, because unless the space station is pointed in the right direction, its solar arrays don't receive the charge they need to keep the space station's systems running. Flight controllers took half an hour to regain attitude control of the space station and return it to a stable configuration. The orbiting outpost has experienced a number of problems in the Russian segment in recent times, with numerous air leaks, and of course that major orbital destabilization back in July, when the thrusters aboard the newly docked Nauka science module suddenly fired up by themselves, spinning the space station some 540 degrees out of alignment. That incident was later traced to a computer problem. The Russian Federal Space Agency Roscosmos says it's investigating this latest incident. This is Space Time. And don't forget, if you're looking for a last-minute Christmas gift or stocking filler, you can help support our show by visiting the SpaceTime store for a huge range of promotional merchandising goodies. There are jumpers, t-shirts, caps and other clothing apparel, cups, coffee mugs, stickers and coasters, neck chains, keyrings, bags and water bottles and heaps more. Just go to spacetimewithstuartgary.com and click on the shop button. And time now to take a brief look at some of the other stories making news in science this week with a science report. New researchers confirm that people who are overweight or obese are more likely to have harsh and longer-lasting symptoms of COVID-19, even if they only get a mild infection. The findings, reported in the journal Influenza and Other Respiratory Viruses, are based on global studies comparing people who tested positive for COVID-19 to their body mass index. Researchers found they were significantly more likely to have a cough, shortness of breath, and a loss of taste or smell once their BMI was above 35. Meanwhile, a summary of people diagnosed with COVID-19 has confirmed that more than half of all people who catch the disease end up with long COVID and have still not returned to normal baseline levels 6 months after diagnosis. The World Health Organization says more than 8 million people have been killed by the COVID-19 coronavirus, with almost 5 million confirmed fatalities and 250 million people infected since the deadly disease was first spread out of Wuhan, China. The United States is warning that Iran is making alarming progress in developing its nuclear capacity. Washington's concerns follow a strongly worded report by the International Atomic Energy Agency warning that Iran has seriously undermined nuclear non-proliferation efforts by the United Nations nuclear watchdog by suspending some nuclear inspections. It says Tehran's actions are preventing the agency's verification and monitoring activities. It comes at a crucial time, with the Islamic Republic continuing to stockpile enriched uranium well above the levels it agreed to in the 2015 Vienna Accords. However, the International Atomic Energy Agency says it's verified that the Islamic Republic's stockpile of enriched uranium now stands at over 3,241 kilograms, more than 16 times the limit laid down in the 2015 United Nations deal. The oil-rich nation insists its nuclear program is exclusively for peaceful power generation purposes only. A study of ancient human excrement has found that people who lived during the Iron Age enjoyed a diet which included blue cheese and beer. The findings, reported in the journal Current Biology, are based on a feces sample showing primitive poop was found to have two kinds of fungi used to make blue cheese and beer. The findings represent the first molecular evidence for blue cheese and beer consumption dating back some 2,700 years. A range of feces samples from the Iron Age through to the 18th century are showing a plant-heavy diet for people, meaning they had gut microbiomes more akin to modern non-Westernized people. Nominations have opened for this year's Australian Skeptics Bent Spoon Award. The award is presented annually to the perpetrator of the most preposterous piece of paranormal or pseudoscientific piffle. Tim Mendham from Australian Skeptics says Ross Coulthard and the 7TV network, together with Peter Ridd, the former professor of physics and head of the Marine Geophysical Laboratory at James Cook University, are among this year's nominees.
It's awarded to someone who makes the most outrageous statements, and sometimes dangerous outrageous statements, or sometimes just stupid outrageous statements. And it has been going every year, and I think it was 1988 that it wasn't issued, but there's been some famous people who have received it, including the ABC several times, including SBS, at least one. Certainly won it. They've probably been nominated more often than that. The only person to have won it twice is our favourite non-celebrity chef, Pete Evans.
The cook.
Just a perennial candidate over the last 5 or so years, but he's actually won it twice, and it was a hands-down choice both times. So nominations are open. The Bent Spoon is awarded at our annual convention, which this year is November 2021, and it is an online convention, so anyone can attend at a very reasonable price. You don't have to come to Sydney. It is a joint venture, actually, between Australia and New Zealand, by the way. So both groups, Australian Skeptics and New Zealand Skeptics, are supplying speakers, and it will be an online event. The awards are announced at the annual convention.
And so far, who are the nominees?
Well, the nominees are Ross Coulthard and the Seven Network for putting on
that. Yes.
Yeah. It's in your area too, so about, astronomy, UFOs and that sort of stuff. Ross puts out these little documentaries every few years, and it basically just rehashes, throws in one new one occasionally. No more accurate, no more sort of definitive proof than the previous one. So he's a bit of a perpetual piffler. There's another fellow named Peter Ridd who was actually making statements that the coral reef, the Great Barrier Reef, is actually doing pretty good, thank you very much. He had a run-in with his university, but not necessarily over those coral reef statements, but more about the way he was interacting with other people at the university. His statements about coral and coral increasing and improving over the years and never having suffered from climate change.
Yeah, he's been really interesting in the way he's been defining it on TV. He's been saying, if you look at the southern coral reef, it's bigger than it ever was, growing well. Yeah, but what does that say about the rest then, if he's only narrowing it down to the southern one-third?
He's narrowing it down to regions and also narrowing it down to years.
Yeah, he's been
right?
very...
A particular year might be better than the previous. Yeah, so it's nowhere near its previous record highs. It hasn't been for the last 30 or so years. Anyway, so he's been nominated. But the top candidates, I think, would have to be Craig Kelly and Clive Palmer, who are generally sort of raising all sorts of fear amongst people about vaccinations, which have some serious implications. So we look forward to the announcements, but we also look forward to more nominees. People can go to our website, which is skeptics.com.au, go to the nomination story and actually nominate their least exciting person to win this award, which is one of the least sought-after awards in the skeptical world, or any world, actually, for that matter. Tickets are available at $40 for the entire weekend. If you want to go to the Skepticon, which is the name of the convention, SKEPTICON, skepticon.org.au, you can get your tickets there, or you can get them through the normal Skeptics website.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.